Hello class, in this video I'm going to talk about calculating opportunity cost using the PPF, and I'm going to be using two different examples with different types of PPFs. We have the increasing opportunity cost PPF represented in this picture right here, and then we're going to have another example with a constant opportunity cost PPF, which is drawn in this example. So let's go ahead and start with this one. So as you learned in the chapter, Production Possibilities Frontier model shows you levels of production, of possible production. It's in the name of the model, production possibilities, possible production points, right? And so just to briefly go over that, we have everything on the red line that represents efficiency. We have that I point right here in the blue shaded area, which is inefficient. And basically anything on the pink area will be unattainable, which means that we cannot produce that because we don't have enough resources. Okay, so let's get to the point. Opportunity cost. So remember, opportunity cost means that when you make a choice, when you choose to do something, you have to give up something. What you're giving up is your opportunity cost. Okay, so we have an example here about calculating opportunity cost on a non-constant, non-linear PPF curve, right? And it's going to be super easy because all we basically have to do is know how to subtract. The only thing that it might be a little bit tricky is that we have to figure out what numbers we're going to subtract. Okay, so we have example number 1 that says, what is the opportunity cost of changing production from A to B? So let's go ahead and pinpoint those production possibilities. So we're talking about A and B. So that's going to be this point on the graph and that point. Let me go ahead and zoom in so we can see the numbers clearly. Okay, so at point A, right, I'm going to write it here. We were producing 50 units of consumer goods. And if you look at the number of capital goods, that's going to be 0. So we don't need to worry about that. So at point A, we were only producing 50 units of consumer goods. Now the question is asking, what about when we go to B? Okay, so now we're at this point, letter B. So we're moving from here to there, right? So we're making a choice. What are we giving up? So at point B, according to the graph, we are producing 48 units of consumer goods now. And by doing so, we gain 10 units of capital goods. So that is what you gained, but that's not the question that we're asking. We're asking opportunity cost. Basically, what it's asking is, if you gain 10 units of capital goods, what are you going to give up? And in this case, basically all we have to subtract is these two numbers, right? So as it turns out, the answer to number 1 is just 2 units of, and remember, we're looking at this axis, so we're only giving up consumer goods. Okay, so let's go ahead and quickly do number 2, number 3, number 4, and number 5. Okay, so now at each point, if you notice, from each point B, C, D, E, we are gaining 10 units, right? 10 units of capital goods. So let's go ahead and just do the quick calculations here. All we're going to do is take the numbers that we have here. We have 43, and then at point B we have 34, and then at point E we have 20. and then at point F we have 0. So these are the numbers that we're going to be subtracting. So when we go to from B to C, sorry, I forgot to circle this one, it means that we're going from 48 to 43. So that means that the opportunity cost is 5 units. 5 units of what? Well, we're still doing this, so it's just of consumer goods, right? So now we go from C to D. So now we're going from 43 to 34. So in this case, we're giving up 9. Right? Of consumer goods. Right? Those quotation marks are just to show you that it's the same thing as above. We're always giving up consumer goods. Right? If we go from 34 to 20, so that's 14 units. And then from E to F, 20 minus 0 is 20. So when you have a nonlinear PPF, basically all you got to do is subtract. You don't have to do much more. You just got to figure out what numbers to subtract. Okay? And again, you figure out those numbers from the points, right? So let's go to something that's a little bit more complicated. Now, we have this example. Let me just read it real quick. Tom is a castaway in an island who must decide between the production of fish and the production of coconuts. If Tom uses all his resources to coconut production, he can produce a total of 30 coconuts per week. If he chooses to use all his resources to produce fish, he can produce a total of 40 units of fish. Okay, so what this paragraph is giving us is information on the total production that Tom can have. Okay, and the big numbers and the important numbers that we have here are 30 coconuts and 40 fish. So that is represented on this graph. Let me zoom out so we can see it. Okay, so how are we gonna calculate opportunity cost with this type of problem? So for this one, since we do have a linear PPF, what this basically represents is that the opportunity cost is not going to change. One thing that I want you to notice about this one, remember that when graphs look like this, which is bowed outward, the opportunity cost is increasing. How is it increasing? We're going from 2 to 5 to 9 to 14 to 20. On this one, it's never going to change because it's a straight line. So all we got to do is set up an equation with the maximum production of each product, and we're going to be able to derive the opportunity cost with this example. So what we're going to do is we're going to set up variables. So coconuts start with a C, so I'm going to start with C equals F for fish. Now, why am I setting them up as equal? Well, you can think about it several ways, but basically you're using the same amount of resources to produce each of these quantities. So if you have all your resources towards coconuts, you're going to produce 30. If you have all your resources towards fishing, you're going to produce 40. Another way that you can think about it is that these 2 points are equally efficient, right? According to our definition of efficiency, anything that is on the PPF, which is this blue line, is going to be efficient. However you want to think about it, as long as you set up this equation, you should be able to calculate the opportunity cost. So now we're just going to use basic algebra, right? So if I want to calculate the opportunity cost of one coconut, then all I got to do is divide by 30. Right? And that gives me a 1C. And here I'm going to have a 4/3 F. And vice versa, right? If I'm solving the other way, I'm going to divide by 40. And so that's going to, without doing the work here, I'm just going to go straight through the problem. It's going to be just the reciprocal. Right? So depending on what variable you want to solve for first, these are going to be your answers. Right? One simple trick that you can use is just once you solve for one, the other one's just going to be that fraction flipped. That's how you can think of it. And notice that the variables change. Here we're solving for C. right here, and here we're solving for f. Okay, so how do we read this? Let's read this first statement. 1c equals 4/3 of a fish, right? So how I'm going to write that is, if I produce 1 coconut, I give up 4/3 of a fish. I give up, meaning opportunity cost. That is my opportunity cost. That portion when I say I give up, that's my opportunity cost. And you can write the other sentence, which would be, if I produce 1 fish, I give up 3/4 of a coconut. That would be this statement right here. That's basically how you calculate opportunity cost depending on what kind of graph you have.